Hello and welcome to Practical Training, the College of Natural Health Sciences, Bermuda. My name is Dr. Delcina Bean Burrows, and this is Foundations of Chemistry. Foundations of Chemistry is actually the first lecture of the Practical Training series of classes that we will have. And no matter if you are a part-time student, a full-time student, or a student who is taking the classes online altogether, you will still have to complete this Foundation of Chemistry lecture because it is the first of all the other classes that we have to do that pertain to chemistry, anatomy, and physiology. And if you do not have a chemistry background, or if it's been a while since you've had any kind of chemistry, then this lecture will serve as the basis of a refresher for you, or it'll give you the foundation that you need so that you will be successful in completing the other classes that when we use biochemical terms or chemical terms, you will already have that covered because it would have been refreshed for you. So that's what we will be doing in today's lecture. And this lecture has an assignment attached to it. You will be required to send that assignment in ahead of the white tunic induction ceremony that we will have shortly. So please enjoy today's lecture and complete the assignment. In terms of our overall lecture objective, in order to understand the complexities surrounding holistic therapies, the clinician in training needs to have an understanding of the fundamental principles of chemistry and the building blocks of life. This lecture will provide this knowledge. These complexities, in part, will become more explicable. However, developments in science dictate that we still have a long way to go before we fully comprehend all aspects of our work. At the end of today's lecture, students will become familiar with the following fundamental terms and principles used to study chemistry: atoms and molecules, elements, compounds, chemical reactions and chemical bonds, transfer of substances, and pH scale. We begin our discussion today by looking at atoms. All matter is made up of a collection of individual particles called atoms. At the center of an atom is a core. This is called the nucleus. The nucleus is made up of particles called protons, which have a positive electrical charge, and neutrons, which are uncharged, i.e., they are neutral. Around this center cluster of particles is a successive layer of electron particles which are negatively charged. These electrons circle very fast and form a cloud around the central nucleus, which is called a shell. The number of electrons is the same as the number of protons, and so there is no overall charge as they complement each other. An atom is given an atomic number, and this represents the number of protons it contains. Molecules. A molecule consists of two or more atoms. Elements are defined as substances that contain only one type of atom, for example, carbon or oxygen. Variants occur among elements due to a slight variation in the number of neutrons. These variants are called isotopes. For example, isotope carbon, which has -14, has 14 neutrons, or isotope carbon, -12, which has 12 neutrons. There are 109 known elements, 90 of which can be found in nature, and these make the building blocks of life. Atoms can gain or lose electrons. This leaves them with a negative or a positive charge. These are called ions. Negative ions are known as anions and are given a minus sign, such as Cl for chlorine. Positive ions are cations and are given a positive sign, such as sodium. Compounds. Elements are not commonly found in their pure state, but form stable interactions with other elements to form compounds, such as water, H2O, which is made of 2 hydrogen molecules and 1 oxygen molecule. Isomers are compounds which have the same chemical formula, but the atoms of which are linked in a different way. The difference in structure means that the compound has different properties. Now let's take a look at organic compounds. All organic compounds contain carbon molecules, such as essential oils. They contain distinct parts known as a functional group. The functional group usually involves oxygen and nitrogen atoms. The rest of the compound involves carbon and hydrogen atoms. Differing combinations of atoms added to the functional group will give rise to different compounds, such as alcohol. When organic compounds react, only the functional group will undergo the chemical change. Inorganic compounds do not contain any carbon molecules. An example is water, H2O. Carbon is quite unique among the elements because of the very large group of compounds it can form. There is an excess of 10 million known carbon compounds. And this will be important to know when we begin to study essential oils. Aliphatic compounds are a good example of these, which contain straight chains of carbon atoms. Aromatic compounds contain carbon atoms joined together in a ring formation, and a good example of this is benzene. Now, in terms of polymers and macromolecules, large molecular structures are known as macromolecules, for example, polysaccharides and proteins. These are made of smaller molecules joined together in long chains and are known as polymers. Now let's look at chemical reactions and chemical bonds. The processes by which different combinations of elements are made or destroyed are known as chemical reactions. Many, but not all, involve the donation or receipt of electrons to form ions. Atoms may be attracted to each other for a variety of reasons. This attraction may be strong and form groups of molecules. This is known as bonding. The atoms are held together because the electrons surrounding the nuclei mix together and become shared. This type of bonding is known as covalent bonding. It generates a holding power or electronegativity between the combined elements. The number of bonds, which is the combining power an atom can make, is called its valency. For example, the oxygen in H2O has a valency of 2. That is, it can make 2 double bonds by combining 1 oxygen atom with 2 hydrogen atoms. The carbon in CO2, carbon dioxide, has a valency of 4. The bond is shown as an equal sign because it bonds twice. That is, it is a double bond. Atoms can also make triple bonds. When a compound is formed, the total number of valencies of the different atoms in the compound will be the same. Bonds may be lost, shared, or gained between atoms. Where electrons are not shared equally, polar covalent bonds are formed and have a negative and a positive end. Now let's consider intermolecular forces. The electrons that form covalent bonds are constantly moving around. The change in the amount of electrons shared can create an electrical charge. The atom with more electrons will have a slight negative charge, and the atom with fewer electrons, a slight positive charge. This exchange will affect all the atoms within the molecule, creating a negative and positive areas. This separation of the charge is called a dipole. If a molecule is next to another with an opposite charge, they will momentarily be attracted. The electron will then move and the attraction will disappear. This is known as a London force. Now let's look at force. Some molecules possess an atom that is positively or negatively charged. A molecule with a negative end, that is, one which is missing an electron, adjacent to another molecule with positive atoms with an extra electron at its end, and vice versa, will create an attractive force by donating or losing an electron. This is described as ionic bonding. The atoms are held by the oppositely charged atom to create a crystal lattice. Hydrogen bonds are less able to attract shared electrons with an oxygen or nitrogen atom. This results in unequal shared electrons, creating an attractive force. This creates a directional charge with the oxygen or nitrogen having a small negative charge and the hydrogen atom a small positive charge. An example would be hydrogen bonds, which are responsible for the large network of molecules that you will find in a glass of water. Now let's look at solids and liquids. Intermolecular forces are also the factor that determine whether a substance is liquid or solid. Solids have atoms or molecules that are closely held together. Intermolecular forces are responsible for many of the processes of the human body. In terms of changing states, temperature determines the state of a substance. Some solids, when heated, change to liquids, and liquids to gas. This occurs because the molecules vibrate, weakening the bonds that hold their atomic structures together. When cooled, the reverse happens as the atoms stop vibrating and the bonds strengthen. Using water as an example, it has three defined stages. The first, from ice when it is frozen, to water when it is not frozen, and then to steam when it is heated. In gases, the forces holding the atoms or molecules are hardly noticeable, and the atoms continually move about. So the question is, why do some compounds not mix? Well, hydrogen bonds are also one reason why oil and water do not mix. The molecules of the oil cannot break the network of the hydrogen bonds holding the water molecules together, so the two substances remain separate. Bonds between different molecules need to be compatible in order to mix. Some molecules mix naturally well together. A good example here is when essential oils are mixed together with a carrier oil. They blend together to create a new aroma. And we'll talk more about carrier oils and essential oils when we study aromatherapy, for those of you who are studying natural health therapies. Emulsifiers are added to products in industry to stabilize substances that don't naturally mix, such as oil and water, to create an emulsion. An emulsifier contains molecules that can be divided into two parts. One end has a positive charge and reacts well with water, and the other end is nonpolar and reacts well with oil. Now let's consider the transfer of substances. How do molecules move? Substances move in a variety of ways, particularly within the human body, as cell membranes have what we call selective permeability. Osmosis is the movement of water molecules from a weak or dilute solution to a more concentrated solution through a semi-permeable membrane to try to gain equilibrium or balance. We also have what is referred to as diffusion, and it is the random movement of molecules in a solute from an area of high concentration to an area of low concentration to create a more dilute solution. We also have what is referred to as facilitated diffusion. Facilitated diffusion uses a specific protein which temporarily binds to large molecules, such as glucose, outside of the cell membrane and then changes shape to facilitate its move into the cell interior where the substance is deposited. We also have what is referred to as active transport. Active transport occurs when substances required by a cell that are at a higher concentrate inside the cell than outside have to be moved uphill. Carrier proteins carry out active transport, and the molecules are pumped into the channels using metabolic energy, such as ATP, and we will talk more about ATP in biochemistry, as well as your anatomy and physiology class. If a cell is surrounded by a weaker solution, it will absorb water. If the surrounding solution is stronger, it will dehydrate and distort. It is vital that the fluid surrounding cells does not become appreciably weaker or stronger so that the cell structure is maintained. And this is what we refer to as homeostasis. And you will be talking quite a bit about and learning quite a bit about homeostasis, especially as natural health practitioners, because this is what we aim to achieve when we give our treatments. Now let's talk about the pH scale and the potential of hydrogen. The pH scale measures acidity and alkalinity. The pH stands for potential of hydrogen. A standard scale has been devised to measure the hydrogen ion concentration. A pH solution below 7 indicates an acidic solution or an acid solution. 1 above 7 indicates that the solution is alkaline. All body fluids have a pH value, and this varies between different secretions. For example, the blood is slightly alkaline at 7.35 to 7.45, whereas gastric juices are acidic at 1.5 to 3.5. Water is neutral and has a pH value of 7. So to end today's lecture, here are some interesting facts, or at least some facts that some people find interesting. First, the kinetic theory states that particles of matter are constantly in motion. The kinetic energy determines both the temperature and the way in which the matter behaves. Acid is derived from the Latin word for sour. Bases are compounds that neutralize acidity. Alkalis are bases that are soluble in water. So there are your interesting facts. So for assignment number 1 for the Foundations of Chemistry lecture, you're going to draw and label a simple diagram of an atom. Also going to define an atom, element, compound, and ion. You're going to state the 3 types of bonding. Also, you're going to describe how molecules move, and you're going to state what does a pH scale measure. Now, this assignment is actually due ahead of the white tunic induction ceremony. So as soon as you get a moment, please complete this assignment, and you're going to email that to collegenhsbda@gmail.com. And I look forward to receiving your assignments. And of course, if you have any difficulty at all with this, please shoot me an email, or you can call me on 703-7327. Other than that, do take care.